This stuff was on the video, wasn't it?
Yes.
Okay. What's that? Okay. Cyclos. Remember, if they're in a continuous cycle, we call them cyclos. So 4 of them is going to be called cyclobutane. 3 of them would be called cyclopropane. There's no such thing as cycloethane. How about cyclo 5? Pentane. Okay. You can add halogens to them. And remember, alphabetical order. If you got ethyls and methyls attached to something, you go in alphabetical order. You mention the ethyls before the methyls. Okay? So you mention the bromos before the chloros, before the fluoros, before the iodos. So, trichloro, fluoromethane. Why did I not put numbers there? Like 1, 1, 1. There's nowhere else to put it. It's pretty much known that it's on the number 1, right? But if I gave you something that looked like this, and then I put like a Cl here and an F there, then you would have to use your numbers, right? 2 chloro, 4 fluoro, what is that, heptane? Yes?
Could you have a seal attached to the seal?
Yeah. What would that be called?
Well, no, like.
You could have it right here.
The shoe is attached to the seal.
Oh, no. Let's think about that. Aren't there extra pairs of electrons here?
Yeah.
Okay, and this guy has 1, this guy has 1. That's where that bond comes in. So this guy is not going to be bonding anymore. Okay? What's this group right here? That's hydroxide. Anytime you have hydroxide, it's called a what? Alcohol. Okay? This is ethane right here. Once you attach an alcohol to it, it's now going to be called ethanol. Okay? Then we get to some other ones. And this is the new stuff. I don't think you learned this stuff last year. Okay? Anytime you have an oxygen in the middle, like that. Okay? And I like to circle these things because that's what I do in bonding, right? And then now we have like ears. 2 little ears for the ether bunny.
Yep.
Remember I mentioned that on the video? So that's how you try to recognize an ether. With the bunny ears. Okay. This one would be called, what's this? That's an ethyl. That's an ethyl. This is going to be diethyl ether. Right? This is a methyl. That's a methyl, so it's dimethyl ether. What if I had that? Ethyl methyl ether. That's exactly right. Alphabetical, right? Ethyl methyl ether. Okay. This guy, what did I say on the video? No haters. No haters. Don't be a meanie.
Yeah.
Okay? So anytime you see that NH2 dangling on an end somewhere, that's going to be an amine. And look what's attached to it. Ethylamine. Ethylamine. What's that? Methylamine. Okay? It'd be CH3 methylamine. Ketone. The way I like to do a ketone is like that. You guys ever see like old antique furniture?
Yeah.
And they have like that skeleton, that fancy looking key that opens it up, okay? Something like that, and then you turn it. That's kind of what I like to look. This looks like a key to me, or a ketone. You kind of see that? Okay. Anything that helps you look at this and so, oh, that's the key, the ketone.
I can see it now.
You kind of see it now? You know, like this would be the ridges.
I got you.
Oh, okay. I'm looking at this one, not necessarily that one. So that's when you have a double bonded oxygen attached somewhere in the middle of the chain there. So this is propane, and ketones are going to have the "one" ending here, so propanone. Okay? If it was on a butane, it would be butanone. Aldehyde, like formaldehyde. That's going to have that double bonded oxygen just like this guy, but it's going to be on the end, not in the middle. So if you see it on the end, it's not a ketone per se, it's going to be an aldehyde. This is ethane, right? Ethanal. So this is going to have an AL ending. I saw one of my students was watching the video, and she was pressing print screen or screen capture as the video was going, and so she has this like printed out as notes. Okay, that's fine. Didn't I give you a piece of paper with the notes on it the other day? It's on the back of that worksheet. That's good too. But what you might want to do is be writing down like what the endings are. Okay, like this right here. Something like that. And it's on the back of that sheet, though. Okay? All right. Esters. An ester, does anybody recognize what's this part right here that I just kind of went over?
Ketone.
That's a ketone, isn't it? Okay. And what's this part right here?
Ether.
An ether. So if you see a ketone and an ether together, that's an ester. Gets kind of confusing, I know. Okay? And look what we have here. This is the longest chain that has the ester. This is an ethyl, right? So it's ethyl propane, ethyl propanoate. The ethyl is attached to the propanoate. That's how you say that. And then finally, carboxylic acids. That's when you look for the coochie-coochie-coo. Okay? This thing right here. Anytime you see a coochie-coochie-coo, that's going to be a carboxylic acid. This right here is ethane, so now we call it ethanoic acid. If it was propane, it would be called propanoic acid. Okay? You have to know these by tomorrow. What? By tomorrow. So, let's recap. Okay? I would think you guys know cyclos. Pretty easy. Alcohols, you should have learned those last year. Okay? I teach this in baby chem. I don't know if you guys learned the fluoros, bromos, okay? So, hopefully you knew all that stuff last year. So, the new stuff. Ether bunnies, look for the ears. Okay? Dimethyl ether. Amines, no haters, don't be a meanie. Okay? Ethylamine. Ketones. Here we go. Ketones. You look for that double bonded oxygen right there. Okay? Look for the key. Propanone, butanone, pentanone. Okay? Aldehydes will have that double bonded oxygen at the very end. Esters are going to have a ketone and an ether. Ketone and ether together is an ester. Ethyl propanoate. And then carboxylic acids have the coochie-coochie-coos. Okay? Ethanoic acid, propanoic acid, butanoic acid. You probably should memorize those tonight. Okay? Let's move on. Let's play around a little bit. What is that called? I don't think it's called. Which one?
Heptene.
Heptene, right?
Yeah.
More specifically, it's called what? 1-heptene. Why did I put the 1 in there? I could have had that double bond anywhere, right? All right, 1-heptene. What if I did this? 1,3 heptadiene. You don't want to say diheptene because what does that infer? That you have 2 heptenes. Heptadiene is telling you that I have 2 of those enes, 2 of those double bonds. Okay? Now, does anybody remember what shape this is? What shape is that? I mentioned it in the video. It's tetrahedral, right? So you got to keep thinking of these three-dimensionally. So when I draw that, which is propane, it actually looks like this, right? Okay. Now watch. Let's say I lie down and I start floating. Okay? And then I move this way and I look straight down on that guy. Isn't it going to look like that? Okay?
Yeah.
So that's why we draw it like that. This is actually what it looks like. It's easier to draw on the board like that. Okay? But there's another way to do this.
Oh,
Where,
yeah.
where the end of the line represents the carbon. So there's a carbon here, here, and here. So what do we call that? Propane. Alright? Cyclo
Pentane.
pentane.
Benzene.
No, I'm not there yet.
Okay, sorry.
Cyclo propane. Methyl cyclo propane.
Dimethyl cyclo.
Close.
1,1 dimethyl.
Thank you. 1,1 dimethyl cyclopropane. Why did she say 1,1? Because what's that? 1, 2. If there's always another option, then tell me what the numbers are. Okay? Good, good. How about 3,5-dichlorooctane. Good. Cyclohexane. Cyclohexene. You don't have to say 1. Because it could be anyone. Now what are you going to do though? 1,3-cyclohexadiene. 1,3,5. I need to write this down. 1,3,5. Cyclohexatriene.
Benzene.
That is a long name, and it's very, very common. Okay, and so we call it something else. We call it benzene to make it a little bit easier. Okay. Now, I don't know if you learned this last year or not, but there's something called resonance, which means couldn't I have put the double bonds here, here, and here? And in actuality, electrons, they move at like the speed of light. That's exactly what happens. Sometimes it's here, sometimes it's there. Sometimes it's here, sometimes it's there. This guy's here, here, here. So it just kind of resonates. You've got this resonating double bond going all around. Okay? So a lot of times they use this to represent it, where it's resonating all around. So that is the symbol for benzene. Okay? Bromobenzene. 1,2-dibromo-benzene. Benzene. How about this? What's the formula for benzene?
C6H.
Every carbon's allowed to have how many things attached to it?
1.
Every carbon is allowed to have how many things attached to it? How many valence electrons? 4. So this is a carbon right here. Carbon, 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 carbon. Now remember, I'm not showing any hydrogens, right? But are they there?
Yes.
Like when I do this, are they there?
Yes.
Yeah. Okay. So this carbon has a bond here, a bond here, a bond here, and how many hydrogens?
1.
1,
6.
1,